All right, we are back. Geometry 4-3, congruent triangles. All right, so today we're going to name and use corresponding parts of congruent triangles, and then we're going to be able to prove that those triangles are congruent. So first, let's talk about congruent triangles. So these would be geometric figures with exactly the same size and exactly the same shape. Okay, so in this case, if we looked at, in this diagram to the right, we're talking about congruent and not congruent. So if you take a look at it, the left box here, when we talk about congruent, you can see that even though they're positioned differently, figures 1, 2, and 3 are the exact same shape and size. So even though, in this one, the tail is over here, we have the same exact tail here and here. They're just positioned a little differently, but those are the exact same size and shape. Where it's different here in the box on the right, where you can see these figures, although they're the same shape, they're not the same size. And so there's a difference between being congruent. You have to be the same shape and the same size. All right. So let's get into corresponding parts. And what that means is that polygons are congruent if and only if their corresponding parts are congruent. Okay, so the entire triangle is going to be congruent only if all of the corresponding parts are congruent. So by corresponding parts, what are we talking about? We're talking about angles, 3 angles, and then the sides, the 3 sides. So in this diagram here, we can list the 6 corresponding parts. First, the angles. And it's easy to see the angles with the arc marks, right? Angle A right here has a single arc mark. Well, so does angle E. So I would go ahead and say, well, angle A is congruent to angle E. And then same with the double and triple arc marks. Angle B would be congruent to angle F. And the triple arc mark as well, you could say that angle G is congruent to angle C. Love that feedback. All right, and then the sides, again, looking at the dash marks. Single dash marks would be congruent, double dash marks, and triple dash marks. So I would say that, side AB is congruent with side EF because they both have the single dash mark through their sides, saying that they're congruent. And then the same thing with the double, FG and BC. And then I would also say the last one would be AC and EG. Those are the triple dash marks. Okay, so those would be the 6 congruent corresponding parts. 3 angles and 3 sides. And that equals the 6 corresponding parts. Now we get into congruence statements. And of course the labels matter, the angles and the sides, the line segments. So now let's get into congruent segments. This is a statement in which all corresponding vertices of polygons are listed in the same order. Okay? And I can't stress that enough because it's going to help you out as you go, but the same order. Same order. And it's just big order matters. Order matters here, okay? Because the order matters, because you can identify all corresponding parts of a triangle without a diagram if you use the idea that order matters here, okay? So for example, if you take a look at the triangles above in our diagram up here, if I just wrote them with a congruent statement and said that triangle, let's you'd call the first one triangle CAB, okay? and I'd say that's congruent to the other triangle, well, the order matters. So I would have to take my angle C, looking at the above congruent corresponding parts here. Angle C goes with angle G, so I would have to name the second triangle starting with G. So it depends on how you name it. And then since angle A corresponds with angle E here, my next one would have to be E. And because B and F correspond with each other, the next thing I'd have to write would be angle F. So it would have to be triangle CAB is congruent with triangle GEF. Now, if I wanted to call it triangle ABC, well, then that would change the name of that second triangle, right? It would be EFG after that. So you just have to make sure that the corresponding sides go with one another and the corresponding angles go with one another. So you can kind of look at, angle C and angle G, and we talked about all the angles going together. But even the segments, you'd be able to tell which ones are congruent as well, because you could look and say, well, side AB here is congruent with side EF. Just even without a picture, you can tell just by the way it's written because they're in order. And you can even go one more segment saying that, if you said starting with B and went back to C, segment BC would be congruent with segment FG. So just by having this congruent statement, you don't even need a diagram. I could tell what angles and what sides were congruent because the order matters. All right, let's take a look at CPC-TC. Okay, a lot of stuff. You see this quite a bit, CPC-TC. It's just an abbreviation for corresponding parts of a congruent triangles are congruent. Okay, so let's take a look at those. Corresponding parts of congruent triangles are congruent. You can see there the abbreviation CPC-TC. And bottom line with that, it's just a reason in a proof, if you're going to prove something. We're not going to do a whole lot of proofs, but in these proofs, the reason you see quite a bit is CPC-TC, because once you prove that these triangles are congruent, then you can easily prove that each part would be congruent as well. Each angle and each side would be congruent. So that's CPC-TC. The third angle theorem, and this one should make a little bit of sense too. If you have two angles of one triangle are congruent to two angles of another triangle, then the third angles of the triangles have to be congruent. So if you knew that two angles of one triangle and you knew the two angles of the other triangle and they're congruent, well then their third angles have to be congruent because they have to add to 180. So if I just drew like a triangle here, let's just make it a right triangle, and let's say I drew another right triangle here in a different direction. Okay, and I said, well, we know those are 90, and let's say that this angle here was 38 degrees, and then this one here was 38 degrees. And let's just say, I didn't know this one, call it X, and I didn't know this one, call it Y. Well, when I look at this triangle, I could say, well, because we have a 90-degree angle here and here, that's one angle congruent, and because this 38 is congruent in each triangle, well, that's two angles of one triangle being congruent to two angles of another. So X and Y would have to be equal, and we could figure that out because we know that have to be add up to 180. So this angle here would have to be 52 degrees, which would mean that Y would also have to be 52 degrees. Because we can easily figure those out. All right? Okay, next, some more properties of triangle congruence, and then we'll get into some practice problems here. So one of them would be the reflexive property. So if you said basically triangle ABC is congruent to triangle ABC, it's going to be congruent to itself if you have like an exact match of that triangle. So that's reflective. So it never looks like the same thing in a mirror. And then if we go to symmetric, symmetric would be if triangle ABC, if we, ABC is congruent with triangle EFG, then EFG is congruent with ABC. Okay? That might be easier if we just kind of give these a label, like say this is triangle 1, triangle 2, and let's use this one as triangle 3. If I basically said, all those letters sometimes can be confusing. If I just said, if triangle 1 is congruent to triangle 2, then the opposite way, symmetrically, would be the same thing. Triangle 2 would be congruent with triangle 1. Okay? Same thing with transitive. Transitive kind of gives you these words using all the letters, A, B, C, congruent with E, F, G, and so on and so forth. But it might be easier just to use it in terms of numbers 1, 2, and 3. So we can talk about transitive in algebra a little bit too. If triangle 1 is congruent to triangle 2, and triangle 2 is congruent with triangle 3, then we could say that triangle 1 is congruent with triangle 3. Okay, so basically you're saying if one thing is congruent to the second, and that second thing is congruent to a third, well, then 1 and 3 would have to be congruent based on their relationship with angle 2, or with triangle 2. So, it's just a different way of seeing the transitive property. Okay, so let's get into some practice problems now. First one says, identify all corresponding angles and sides, then write a congruence statement. Okay, so first, we start with angle, start with one side. So if I just start with this first one and say, well, let's go, angle S is the first one right here, right? So it's got four arc marks. So if I just said angle S, and let's just go along in order here. So let's just go around, let's go counterclockwise, S, R, Q, P. So if I said angle R, what would that be congruent to? Angle Q and angle P. They would be congruent to what? So I can kind of look at the other side. So I'm just kind of looking for which one has 4 arc marks, right, for angle S. Well, D is the one that has 4 arc marks, right? So angle D has to be congruent with angle S. And then I kind of just go around. Angle R has 3 arc marks. Angle E would be the corresponding congruent angle. And it's tricky because, notice I'm going in this direction here, but here I'm going to go this direction, looking for 3 arc marks, right? So angle Q has 2 arc marks, so that would be congruent with angle F. And then angle P would be congruent with angle G. So they're just kind of orientated a little different, right? They're one is upside down, I guess you could say, or just kind of flipped around, rotated a little differently. So look for the arc marks and dash marks. Okay, same thing with the sides. If I started with, say, side, I could start with the other shape as well. If I said side DE, just to show you can do that. Side DE has 3 dash marks. So I'm looking for the side on the first shape that has 3 dash marks, and it would be side SR. Segment SR. Okay, and then I'm going to continue on and say EF would then be congruent to RQ because they both have three arc marks as well, and their angles are corresponding as well. And we'll continue on with that, say FG and QP, and GD and PS. Okay, so that would be all the corresponding angles and sides in these two shapes. And then we want to write a congruent statement. So my congruent statement is they're 4-sided shapes, so they're quadrilaterals. So I would say quadrilateral. And if we just kind of we went around on the right shape. We started with S and then went S, R, Q, P. Well, then because order matters, My next shape would have to be quadrilateral, and we'd have to go in that same corresponding order. So since S corresponds with D, we would say it would start with D, and we know that R goes with E, and then we'd have to say F and G, right? Because Q goes with F, and P goes with G. And sometimes if you can get the congruent statement first, it makes a lot of the other stuff a lot easier, because you could easily see that S goes with D, and say Q goes with F, and so on and so forth. You can kind of figure that out to get the congruent statement first. So sometimes that's not a bad way to go, get the congruent statement first. Okay, a couple more. All right, this one, in this diagram, it says we've got a triangle with a bunch of measures and angle measures, and we want to find X and Y in the second triangle. Okay, so the key here is to look at this box right here, because it says that triangle ABC is congruent with triangle DEF. So because of that congruent statement, I know certain things. If I'm looking at Y is an angle F, I know that angle F is congruent to angle B because this triangle congruent statement says so. So I know that angle B is congruent to angle F. So because of that, I can plug in B, I can plug in 99, because that was given to me here, and it's equal to 8y minus 5, because that's what F was right here. That's what we're trying to find, right? So now I can do algebra to solve this one. So I'm going to add 5 to both sides. That gives me 104 equals 8y, and then when I divide by 8, I end up getting y equals 13. Okay? So that's part of it. Now, on the other side, let's try to find x. Well, where's x? X happens to be right here. Okay? But there's also a y in this one, and that side, FE, corresponds with 38.4, because you can see that these two sides would have to be congruent based on your congruent statement. So on that one, I can say that side FE is congruent with side BC. And so FE is 2y plus 4, and BC is 38.4. Those are given to me here and here, okay? But now I have 2y, oh, sorry, not 2y plus 4, it's 2y plus x, isn't it? Yeah. Okay, so now what I'm going to do is I have two variables. I have a y and an x, but because I know that y is 13 here, I can plug it in right there. And so that becomes a 26, so it's really 26 plus y. So from there, I'm going to subtract 26 from each side, and I'm going to have x on one side. Equals 38.4 minus 26, which is 12.4. So you found x and y, right? You've got 12.4 here, you've got your y equals 13 there, and you've solved that question. All right, the next one. We're going to let you kind of work on this on your own, but again, remember that they're giving you the figure that triangle LNM is congruent to triangle QSR. So find x and y, kind of the same way you did number 2. You know, you're going to look at these corresponding statements and say, all right, this angle, what is this angle equal to? So pay attention to this, the corresponding sides. What angle would M be equal to? Well, M would have to be equal to angle R here, right? Because M is listed third, R is listed third. So you can find that for Y, and then which sides match up for the X's. So kind of work on that on your own, and we'll kind of take a look at it again when we return. Okay? That's it for section 4.3. A lot to it, but you know, like I said, bring your questions. Hopefully we got everything set. All right, thanks.